Hi all, welcome to Go Classes. So let's start the discussion of today's DPP. Today we have Knight-Knaves problems. Today I gave only three problems, only three questions, not five. The reason is these might be little bit hectic for many students. Okay, these Knight-Knaves problems. We will see how to solve Knight-Knaves problems for in general. What is the general template? What is the best way to solve these type of puzzles, Knight-Knave puzzles? Okay, so this is what we are going to discuss. Now let's start. So before we start, let me know audio, video, volume, echo, everything is perfect. Is everything fine? So let's start the discussion session. Audio, video, volume, echo, everything is fine, right? Okay. Hi all, welcome to Go Classes YouTube DPP series for Gate CS, Gate DA, GOAT DPP series. Today's DPP is Discrete Mathematics subject, Propositional Logic topic, and the questions are based on Knight-Knave puzzles. These are very famous type of puzzles, and in the GATE exam, questions have come based on Knight-Knave puzzles. Without using this Knight-Knave word, they have asked questions in the GATE exam. In the GATE mechanical, they have already asked Knight-Knave puzzles directly with the name Knight-Knave. Okay. In the GATE CS also, multiple questions are there which are not using the word Knight-Knave. Instead of Knight-Knave, they are using the word type 1, type 2, like that. Okay. So let's solve the questions. Let me tell you that the GOAT DPP series, means Go Classes YouTube DPP series for GATE CS, GATE DA, the complete playlist link you can find in the description, also in the pinned comment. All the questions in our YouTube DPP series will be taken from standard resources to ensure that you practice top quality questions. All the questions will be within the GATE syllabus, and the difficulty level will be within the GATE difficulty level. So on YouTube, you can just search GATE CS DPP. This is what you can search, and then you can see the Go Classes DPP video will show. Okay, here you can notice this is the complete playlist link. GATE CS GOAT DPP series playlist link. The complete playlist link you can find here. So on YouTube, just search GATE CS DPP, and this playlist will be there. You can see this complete playlist will be there. GOAT DPP series, GATE CS Go Classes YouTube DPP series. Okay, so you can just check it out. This playlist you can check it out. Okay, let's solve this question. This is GATE Mechanical 2017 question based on Knight-Knave puzzles. Let's solve this question and let's see what is the general template, what is the best way to solve Knight-Knave puzzles. So let's see here. All people in a certain island are either knights or knaves, and each person knows every other's identity. Each person knows every other person's identity. Knights never lie, knaves always lie. Now P says both of us are knights, Q says none of us are knaves. Which one of the following can be logically inferred from the above? Here, remember, there is an island. On this island, there are only two type of people: knights, knaves. Now, if someone is not knight, if someone is not knight, then that person is knave. If someone is not knave, then that person is knight. So basically, not knight means knave, not knave means knight. So because on this island there are only two type of people, knights will always tell the truth. You can see knights will never lie. Read this, that knights will always tell the truth, means whatever knight will speak, that will be true, that will be truth, that will be true. Now you can see knaves will always lie. Whatever knave will speak, that will be false. Okay. Now PQ, we don't know what they are. They can be both knight, both knave. One of them can be knight, one of them can be knave. So you can see P says both of us are knights and Q says none of us are knaves. Now, what we will do? First, let me tell you the general template. What is the way to solve? What is the method to solve? So let me tell you the method to solve. Most of the questions based on Knight-Knave puzzles you can solve like this. So let's see what is the best method to solve. First, you have to understand few certain things. For example, remember if someone is not knight, if someone is not knight means negation of knight, what that will be? If someone is not knight, then definitely they are knave. And if someone is not knave, then definitely they are knight. Because only two type of people are there, knight, knave. Knight will always speak truth and knave will always speak lie. Now, one more thing, what you do? Knight you denote by K. Okay, let's denote by K. Means when I write K, it means it is knight. So, and remember, knave, let's denote by N. Okay, so this is what we are going to denote. This is our abbreviation. The reason is because when you are solving the question, you are not going to write, these big words, knight, knave, knight, knave. Okay, so in short, these are our abbreviations. Correct? So I can simply say that if someone is not knight, then they are knave. If someone is not knave, they are knight. Okay, so these are the things that you must understand. Now, the next thing is, if there are, let's assume people, let's assume there are people PQ. Okay, PQR like that. So let's assume these are the people PQ. Now, if I want to say that P is knight, then what I will do? I will write PK. So you can see if I want to write that, okay, P is knight. If I assume it or if I write it, then how to write it? Remember, in short, you just write it PK because K means knight. Okay, or you can write it like KP. That is, both are fine. So this is what we are going to use. That P is knight means we will write PK. And you can see if I want to say that Q is knave, if I want to write Q is knave, then I will write QN. Okay, now you tell me, if I want to say P is not knight, P is not knight, then what that will mean? It means P is knave, definitely, yes or no? If I want to say that P is not knight, then definitely P is knave. And if I want to say that Q is not knave, then definitely Q is knight, because there are only two type of people, knight, knaves. If someone is not knight, they are knave. If someone is not knave, they are knight. Okay, correct. So I hope you understood all these abbreviations, all these conventions. Simple. Okay. Now let's see this question now. So what P says, what Q says, let's write. So now you can see what P says. Coming to our problem. Okay, coming to question. Coming to question. So far, what we have seen, that was just general guidelines. Okay, these are basically just general guidelines. So far, these were just general guidelines. Now let's see. Let's come back to our question. What P says? P says both of us are knights. I don't know whether P is speaking truth or false. I don't know. If P is knight, then he is speaking truth. If P is knave, then he is speaking false, or I can say lie. But what P is saying, let's write it. P is basically saying that both of us are knights. Means what P is saying? P is saying that P is knight and Q is knight. Correct? This is what P says. And tell me what Q says. Q says that none of us are knaves. None of us are knaves. What it means? It means both of us are knight. See, Q says that none of us are knaves. Means P is not knave, negation of Pn, and Q is not knave. Now, here what I can say, remember what is negation of Pn? P is not knave. This whole thing, P is not knave. It means P is knight. And Q is not knave. It means Q is knight. Now, you can notice one thing, that P and Q, they are basically saying the same thing. Yes or no? P is also saying that both of us are knight. Q is also saying that both of us are knight. Did you understand? Remember what this means? This means that P is not knave. If P is not knave, then P is knight. If Q is not knave, then Q is knight. Correct? So you can see that P and Q, they are basically saying the same thing. Okay, so finally I can say that P, Q both are saying, both say, both are basically saying that we both are knight, means P is knight and Q is knight. Okay, now we need to find out whether they are knight, whether they are knave, which of them is knight, which of them is knave. Okay, this is what we need to find out. So let's see. Now let me tell you, you need to apply by case method. The best way to solve this type of question, the best way to solve knight knave question, so the best way is basically that is by case method. You make cases by cases. Okay, or if the question is really very complicated, then truth table. The both the methods we will apply for this question, don't worry. So you can see, either you make cases or you make truth table. Okay, and you can see if you have only two people like PQ, then you can just go for truth table. If you have three people, then if you go for truth table, then there will be total 8 rows. So remember, here we only have two people, PQ. So what you can do, you can just make truth table. Okay, so this is the best way to solve the knight knave question. And remember one thing, that whatever case you consider, you just make sure that all the given conditions must be consistent. Anything that is given in the question, that must be consistent. Okay, so let's see what it means. Here I can make total 4 cases I can make. Notice, let's make truth table. Let's solve using truth table. So you can see we have two people PQ. Now what are the possibilities? Both can be knight. These are the possibilities. Both can be knave. Correct? One of them is knight, one of them is knave. So you can see these are the 4 possibilities. Here you can see P is knight, Q is knave. Here P is knave, Q is knight. The point is there are total 4 possibilities. Now in this case, what P says, what it becomes. Okay, basically here you can see in this case, what P says, what it becomes, means does it become true or does it become false. And in this case, let's see what Q says, what does it become. And then let's see consistency, means is everything consistent. Consistency. Okay, see now, if you take both of them are knight, then what it means, in this case both of them are basically they are saying the truth. Correct? Yes or no? Now you can see if both are knight, then definitely they are saying truth, that we already know. But what P actually says, what that becomes. See, I am just asking what P actually says, the truth value of what P actually says, truth value. Truth value of what P actually says. And similarly, truth value of what Q actually says. Now remember, don't write that, okay, P and Q are knight, so what they are saying that is true. No, I am saying that what they are actually saying, you find the truth value of that. What what Q is actually saying, you find the truth value of that. So you can see, if I make this case that P and Q both are knight, then this is what they are saying, this is what they are actually saying. This is what they are both are actually saying. This is what they are actually saying. So now you can see, if P and Q are both knight, means in the case 1, then definitely they are saying the truth, because this will become true. If I assume that P and Q are both knight, then P knight, this will become true. Q knight, this will become true. True and true, that will become true. So what they are actually saying, that will become true. Means what Q is actually saying, that will become true. What P is actually saying, that will become true. Okay, correct? And you can see, is it consistent? Yes, it is consistent, because P and Q are knight, so they must speak truth. So yes, this is consistent, because since they are both knight, so definitely they must speak truth, and yes, they are speaking truth, so consistency is there. Now let's see the second case. In the second case, P is knight, Q is knave. So P is knight means this is true. Q is knave means this is false. True and false, that is false. Correct? So you can see what they are actually speaking, that is false. Do you agree with me? In this case, think about this particular case. In this case, P is knight, Q is knave. So P knight, that is true. That is true. Q knight, that is false. Because in this case, Q is knave. Okay. So here you can see that true and false, that will be false. So what they are actually speaking, that is false. So I can say that what P is actually speaking, that is false. What Q is actually speaking, that is false. Now tell me, what about consistency? Consistency is gone because remember, P is knight. How can he speak the false? Yes or no? In this case, P is actually knight, so he must speak true. But what he actually speak, that is false. So the consistency is gone. So I can say that this case we can discard. Let's see the next case. Q is knight, P is knave. Now, in this situation, what they are actually saying, let's find the truth value of that. So you can see, if P is knave, then this will be false. If Q is knight, this will be true. False and true, that will be false. So means what they are actually speaking, that is false. They are actually speaking false. But you can notice Q is actually knight. So how can Q speak lie? Q is knight, so he must speak the truth. So definitely here also consistency is gone. So this case also you can discard. Now let's see the last case. If both are knave, then you can see P knight will become false, Q knight will become false because both are knave. Okay, so P knight, Q knight, they will become false. False and false, that will be false. Means what they are speaking, that is false. P, Q, what they are speaking, that is false. P is speaking false, Q is speaking false. Now tell me, what about the consistency? Now the consistency is there because both are knave, they must speak the false. Yes, they are speaking false. Do you agree with me? Both are knave, so they must lie. They must speak false. Yes, they are speaking false. So again, there is a consistency here. When both are knight, they must speak truth. So you can see here also there is consistency. And when both are knave, then they must speak false. Here also there is consistency. So you can see what we found out from the information given, from the information that is given to us. Now we can't conclude. One thing we can conclude that either both are knight or both are knave, but we can't say which of them. Okay, yes or no? So you can see that the final answer is that either both are knight or both are knave, but we can't conclude which one of these is true. Okay, so I can say the final answer. The final answer will be here for this question. The final answer will be the identities of PQ cannot be determined. I hope you understood. So remember, one thing we can guarantee that PQ, either they are both knights or both knaves. This we can guarantee. Other than that, we cannot say anything. This is the final conclusion. This is the final conclusion. Means this is what we can say. What we can say. We cannot say more than that. So I can say that we cannot actually find their identities. We can simply say either both are knight or both are knave. This we can definitely say this is false. Okay, but remember, we cannot say that they are knight. See, this is definitely false. This is option B is certainly false. Look at this. Certainly false. Now you can see both are knight. We can't say. We cannot say. Both are knight. We cannot say. And you can see both are knave. We cannot say. Okay, so final the answer will be option D. I hope you understood. Is this clear to everyone? Tell me. So remember the knight knave puzzles, these are actually much easier. Just remember one thing, that if someone is not knight, they are knave. If someone is not knave, they are knight. The negation of knight is knave. The negation of knave is knight. And then you apply the by-case method or you apply the truth table. If there are only two people, PQ, like that. Okay, if there are only two people, then what you can do? You can just apply the truth table and then you check the consistency. You make the truth table PQ can be both knight, knave, knight, knight, knave, knave, knave. These are the four cases. Now, in these four cases, you see the truth value of what they are actually speaking. This is what you find. You find the truth value of what they are actually speaking. And then you check the consistency. If I am knight and what I'm actually speaking, that is true, then there is consistency. Because I'm knight, what I'm actually speaking, that is truth. So there is a consistency because I must speak the truth. If I'm knave and what I'm actually speaking, that is truth, then there is inconsistency. Because if I'm a knave, then I must speak false, I must speak lie. Okay, so then you just check the consistency. In any case where consistency is gone, that case is gone, discard that case. But in any case, if consistency is there, consistency of everything that is given in the question, every information that is given in the question, if that is consistent, if that is consistent, then that is your answer. Okay, I hope you understood. So this was a beautiful question. Please tell me, did you understand this? In the Go classes weekly quizzes, in the Go classes test series, many night new puzzles I have already put. In the gate CS, already a question has come. They did not use the word night nave, they were using the word type 1, type 2. In the gate mechanical, this night nave question has come. In future, this question can come in the gate CS also. Already a question has come in the gate CS. Type 1, type 2, this type of question has come. Basically, there, type 1, type 2, these were basically night nave. The point is, this type of questions can come in the gate exam, already have come in the gate exam, in the gate mechanical, in the gate CS. Okay, in the future also they can come. And in the Go classes test series, in the Go classes weekly quizzes, you will find many questions based on this template. These are, to be honest, these are confusing questions. These are not hard, these are confusing questions. You just have to make cases. Either you make cases or you make the truth table, then your life will be very easy. And remember these few things, like negation of knight is knave, negation of knave is knight. So these few things, if you understand, then easily you can solve the question. I hope you understood. Always check the consistency. Whatever information is given in the question, you check if that is consistent or not. Let's solve this question. This question is taken from UC Davis University. This question is also basically based on knight knave puzzles. They are not using the word knight knave, but basically this is a puzzle similar to knight knave puzzle. Okay, this has the same template as the knight knave puzzle. So let's solve. Let's read the question. This is a beautiful question. Let us play a logical game. You find yourself in front of two rooms whose doors are closed. Behind each door, there could be a lady or a tiger. There are two rooms, room 1, room 2. Behind room 1, you can have a lady or a tiger. Behind room 2, you can have a lady or a tiger. So there are basically total 4 cases possible. Lady, lady, tiger, tiger, lady, tiger, tiger, lady. Correct? Now, there is one sign on each door. You can see on the room 1, this sign is there. Both rooms contain ladies. This is the sign. This is written on the room 1. And this is written on the room 2. Both rooms contain ladies. You are told that if the first room contains lady, then the sign is true. But if there is a tiger in the room 1, then the sign is false. In the room 2, this situation will become opposite. Means if there is a lady in room 2, then the sign will be false. And if there is a tiger in the room 2, then the sign will be true. And these are the signs. Can you say what is behind each door? If this question comes in the gate exam, then there will be 4 options. The 4 options will be, lady, lady, tiger, lady, lady, tiger, tiger, tiger. So this question can easily be converted into MCQ question very easily. Okay, now let's see this question. One thing you notice, that there are only two type of people, either lady or tiger. If someone is not lady, then that is tiger. If someone is not tiger, that is lady. Do you agree with me? Okay, so here remember there are only two type of people, only two type of people we are considering, or I can say only two type of entities we are considering. Here you can see lady and tiger. Lady and tiger. Now you can see Behind a door, if you don't have lady, then definitely there is a tiger behind that door. Correct? So I can say negation of lady will be tiger. And behind a door, if you don't have tiger, then definitely there is a lady behind that door. Okay, correct? So simple things. Now let's see here. Here what we can do, I told you that this type of questions you can easily solve using the by case method or using the truth table. Now let me solve this question using both the methods. Correct? So let's solve it using method 1 to solve this question. First let me use the method 1, then we will use the method 2. Method 1 is by case method. By cases. So case 1, only two cases are possible from the room 1 point of view. What is the case 1? Case 1 has, case 1 is that room 1 has lady. Okay. And what is the case 2? Case 2 will be room 1 has tiger. Correct? Yes or no? Only two cases are possible. Case 1 is room 1 has lady, and case 2 is room 1 has tiger. Okay. Now let's see. Only two cases are possible, correct? So let's see the first case. If room 1 has lady, then what the question is saying? Read the question. You are told that if the first room contains lady, then the sign is true. But if the first room contains tiger, then the sign is false. So you can see we are already saying in the case 1, we are already considering that room 1 has lady. So I can say in this case, so I can say sign of room 1 sign is true. Do you agree with me? So room 1 sign is true. This is given in the question that if there is a lady in the first room, then the sign is true. So room 1 sign is true. And what is room 1 sign? Room 1 sign is basically saying that both rooms have lady. Okay, this is the room 1 sign, that both the rooms have lady. Okay, both the rooms have lady. Both rooms have lady. Okay, correct? Ladies. So both rooms have ladies. Now you can see one thing. Already room 1 has lady. So I can say that this, look at this, that room 1 has lady and room 2 has lady. This is the sign, right? Room 2 has lady. See, I am saying that. Notice this statement I can convert to this, correct? Both are same, because we, you can see the room 1 sign that is saying both rooms have ladies. It means room 1 has lady and room 2 has lady, correct? Now you can see one thing. Room 1 already has lady in this case 1. So this is true. Room 1 has lady. This is true. Very good, no problem. Now you can see, what about room 2 has lady? But remember, if room 2 has lady, then what will happen? Read this, that in the room 2 the situation is opposite. If there is a lady in the room 2, then the sign is false. Means this sign must be false. Do you agree with me? Notice one thing. In the case 1, room 1 has lady, room 2 has lady. Okay. But if room 2 has lady, then the room 2 sign must be false. Correct? In this situation, room 2 has lady. In this situation, room 2 sign must be false. In this situation, I can say room 2 sign must be false. But what is room 2 sign saying? Room 2 sign is that both rooms contain lady. If that is false, then room 1 is saying both room, see, room 1 is also saying both room contain lady. And in the case 1, this is actually true. But if room 2 has lady, then this sign must be false. So there is a contradiction here. Do you agree with me? There is a clear contradiction. If room 1 has lady, then both room must have lady. But if room 2 has lady, then both room having lady must be false. So there is a clear contradiction here. I hope you understood. Is this clear to everyone? Because you can see room 2 false, room 2 sign will be false. What it means? It means that both rooms cannot have lady. Not both rooms have lady. it means not both rooms have lady. Not both rooms have lady. Now there is an inconsistency because here you are saying that both rooms have lady, and here you are saying that not both rooms have lady. So clearly there is an inconsistency. So finally, case one you can discard. Is this clear? So you can see here. Let me say that you can see this point and look at this point. If you focus on these 2 points, then there is an inconsistency. So definitely case one discarded. Okay, I hope it is clear. See, case one was actually very easy. You can see if you assume that room one has lady. Let me put. You can see if room one has lady, then this statement must be true. If this statement must be true, then both rooms must have lady, means room two also must have lady. In this situation, if room 2 has lady, then this statement must be false. But notice one thing, both are the same statement. How it can happen that same statement is, true, same statement is false? So there is a contradiction. Okay. I hope now it is clear. If someone had any confusion, then I hope now it is clear. So I can basically, I can explain from this diagram. I think that will be much easier. You can see that this is the case one we are considering. Okay. What was our case one? Case one was room one has lady. Room one has lady. Okay, this is our case one. So in this case, room one already has lady. There is a lady in this room one. So you can see from the given information that if there is a room, if there is a lady in the room one, then this statement must be true. Okay. But if this statement is true that both rooms contain lady, then automatically room 2 also will have lady. But if room 2 has lady, then this statement must be false. The sign of room 2 must be false. You can see the sign of room 1, room 2, both are basically same. Both rooms contain lady, both rooms contain lady. So the same statement is true, the same statement is false. That is the contradiction. That is the contradiction. The same statement, how it can be, true and false. So that is the contradiction, or I can say inconsistency. That is the contradiction here. So one thing you can definitely guarantee, that room 1 has tiger. This is the conclusion you can give, that room 1 definitely has tiger. Okay, is this clear? Very simple. So now let's see the case where room 1 has tiger. Let's check that case, correct? Okay, so this is the conclusion we got, that room 1 has tiger. Now you can see the case 2 is actually the correct case. Okay, this is the actually correct case, that room 1 has tiger. Now we just have to check what is behind the room 2. This is guaranteed, this is correct. Okay, yes or no? This is guaranteed to be correct, that room 1 has tiger. Now we just need to check what is behind the room 2. So you can see it is certain that room 1 has tiger. This is what we have found. Okay, yes or no? So room 1 has tiger. Now you can see if room 1 has tiger, then this sign must be false, correct? The question is saying if there is a tiger in the room 1, then the room 1 sign must be false. So this sign must be false. And now if this sign is false, now let's check what is there in the room 2. In the room 2, is it possible there can be lady? Just check this case. Is it possible that there can be lady, or is it possible there can be tiger? Let's check. Is it possible there can be tiger? Means this is what we are checking. This is what we are checking. Is it possible that room 2 has tiger? If room 2 has tiger, then the sign, room 2 sign must be true. Do you agree? You can see if there is a tiger in the room 2, you can read this. If there is a tiger in room 2, then the sign must be true. So in the room 2, if there is a tiger, then the sign of room 2 must be true. Now you can see both rooms contain lady. This is true, but here you are saying this is false. Again, there is an inconsistency. Do you agree with me? Again, there is a contradiction here. Again, there is a contradiction here. Okay, because you can see here you are saying that this statement is false. Here you are saying this statement is true. So definitely there is a contradiction. So, what I can say? So what I can say that room 2 definitely does not have tiger. Correct. So room 2 has lady. Okay. You can check if room 2 has lady. Now you can see. Now you can see there will be no contradiction. Let's check. Let's assume that room 2 has lady. Now there is no contradiction because you can see if there is a lady in the room 2, then the sign must be false. So you can see this statement must be false. You can see the same statement is false in both the places. Here also this statement is false. Here also this statement is false. So there is no contradiction. Yes or no? You can see both rooms contain lady. That is clearly false because one room has tiger, one room has lady. So you can see this statement is false. This statement basically same statement is basically false in both the cases, and you can see that there is no inconsistency. There is no contradiction here. Everything is perfect. Correct. Okay, you can see that there is a tiger in the room 1, so definitely this statement must be false. Yes, this is false because there is a tiger in one room and there is lady in another room, so definitely this statement is false, and this statement must be false. It must be false and it is false. This is what I'm saying. This statement must be false and this is false, so I can say consistency is there. You can see in the room 2 there is a lady, so this statement must be false and this is false, so that is consistency. So you can see finally this is the answer. I hope you understood. So finally the answer will be what? That room 1 has tiger and room 2 has lady. Okay, is this clear? Now the same question you can solve using another method, that is method 2. Let's see that method also, that is truth table. Because there are only two type of people. Truth table, or basically there are only two rooms here. We just have to consider four cases what is behind the room. Correct. So I can just make truth table. What I can do, I can make truth table like this, that okay, these are the cases, what is behind room 1, what is behind room 2. So you can see both have lady lady, lady tiger, tiger lady, and tiger tiger. These are the four cases possible. Now let's check in this situation what about the sign of room 1 sign. Room 1 sign actual truth value. Let's find room 1 sign actual truth value. Room 1 sign actual truth value. And also let me find the room 2 sign actual truth value. Room 2 sign actual truth value. And in the last column, let me put is everything consistent. Okay, here let me put consistency. Okay, so let's check the consistency. I hope you understood. Now you can see if both have ladies, if both rooms have ladies, then here you can see, let's check it here. So if both rooms have lady, then what about the actual room 1 sign actual truth value? You can read it here. The room 1 sign is both rooms have ladies. Okay, so you know the room 1 sign, right? The room 1 sign is both ladies, and the same is room 2 sign. Room 2 sign is also both ladies, both room have ladies. Now you can see in this case where room 1 room 2 both have lady, then the room 1 sign actual truth value, that will be true. Okay, because the room 1 sign is saying that both have ladies, so this will be true in this case because both have lady, both room have lady, so the room 1 sign actual truth value will be true. And you can see in this case where both have lady, then the room 2 sign actual truth value, that also will become true. Okay, so room 1 sign, room 2 sign, actual truth values, they are true, true. What about the consistency? Notice one thing. If there is a lady, if there is a lady in the room 2, then actually room 2 sign must be false. Do you agree with me? Correct? Yes or no? What is the consistency condition? Let me write it here. What is the consistency condition? What are the consistency conditions? The consistency conditions, please understand that if room 1 has lady, then if room 1 has lady, then room 1 sign true. Okay. And remember, if room 2 has tiger, then room 2 sign must be true. Okay. And similarly, there are two more, that if room 1 has tiger, then room 1 sign must be false. Okay. What you can do? You can say that if room 1 has tiger, then room 1 sign must be false. And similarly, I can say if room 2 has lady, then room 2 sign must be false. Okay, this is the consistency conditions. Is it clear? They must hold. They must hold. Now let's see. Let's check. In this case, where both room have ladies, then you can see room 1 sign actual truth value, that is true. That is consistent. There is no problem here. But you can see room 2 has lady. If room 2 has lady, let's see the last case. If room 2 has lady, then room 2 sign must have false truth value. But you can see the room 2 sign is getting the truth value true. So this is the problem. So inconsistency, yes or no, consistency is gone. Now let's see the next case. If room 1 has lady and room 2 has tiger, then what about the room 1 sign actual truth value? You can see room 1 sign is saying both have ladies, and room 2 sign is also saying both have ladies. But in this case, where one room has lady, another room has tiger, the room 1 room 2 sign, the actual truth value, that will be false. In this case also, the actual truth value will be false. Okay. In this case also, the actual truth value will be false. Correct? Because what are the actual signs? You can see the room 1 sign is both ladies, both room have ladies. The room 2 sign is both rooms have lady. Now you can see in these three cases, the actual truth value of room 1 sign, room 2 sign, that will be false. So you can see, very simple. Now let's check the consistency. In this case, where room 1 has lady, room 2 has tiger, in this case, is there any inconsistency? You can see room 1 has lady, so the room 1 sign actually must be true. There is a problem here. Okay, because if room 1 has lady, read this, if room 1 has lady, then room 1 sign must be true. But here you can see the room 1 sign is false. So there is a problem here. So the inconsistency means consistency is gone. Now let's see the next third case. If room 1 has tiger, then you can see, if room read this, if room 1 has tiger, then room 1 sign must be false. Yes, room 1 sign is false. So there is no problem here. Now let's see it here. If room 2 has lady, if room 2 has lady, then room 2 sign must be false. Yes, room 2 sign is false. So here I can say that there is no inconsistency, or I can say consistency holds. Now let's see the last case. Both room have tiger. If room 1 has tiger, then you can see, if room 1, if here look at this case, if room 1 has tiger, then room 1 sign must be false. Yes, room 1 sign is false. So this is perfect, no problem. But room 2, if room 2 has tiger, you can see, if room 2 has tiger, then room 2 sign must be true. If room 2 has tiger, then room 2 sign must be true. So you can see that here there is a problem, and consistency is gone. So that's it. So finally the answer will be what? There is only one case where consistency holds. So the final answer will be that room 1 has tiger and room 2 has lady. This is the final answer. I hope you understood. So did you understand? Please tell me. This is how you can solve these questions. Remember all these puzzle type of questions, Knight-Knave questions, this lady tiger question, type 1, type 2 people question. Basically, all these type of questions which are based on this template, Knight-Knave template, all these questions, these might be confusing, but if you do practice, you will find that they are very easy to solve if you just make cases and if you check the consistency. Here you can see we have only two room 1, room 2, only four cases we need to consider. Lady tiger, tiger lady, lady lady, tiger tiger. Four cases we need to consider. In these four cases, you check the consistency holds or not. Similarly, in the previous question, the gate mechanical question, there we have two people PQ. We need to consider only four cases. Knight, knight, knave, knave, knight, knave, knave, knight. And in these four cases, you check the consistency holds or not. All these questions based on Knight-Knave puzzles, based on Knight-Knave template, all these questions, you just have to check the consistency, nothing else. Okay. And with practice, actually these questions will become very easy because I'm explaining to you using multiple methods. Okay, so that is the reason it might feel that it is taking time, but if I solve it myself without explanation, if you give me the question, if I solve it myself, then very quickly I can do. You can also do with practice. Within 1 minute, you won't even need 2 minutes. Most of the questions you can solve within 1 minute. Okay, so we will do a lot of practice. Let me tell you that in our go classes YouTube DPP series, what I will do in the future DPPs also, I will take this type of questions, Knight-Knave template questions, this type of puzzles I will take. I hope it is clear because already a question has come in gate CS, gate mechanical. So in the future also it can come. So we should be ready. We should have done enough practice that we are comfortable with this type of questions and we can quickly solve. It should not happen that we are spending 5 minutes, 10 minutes to solve the question. This is the explanation given by the university. You can see the question was taken from UC Davis University, right? This lady tiger question was taken from UC Davis University, and this is the official explanation. You can pause the video and you can read it. You can see they are also creating truth table, room 1, room 2, and they are creating the truth table and they are checking the compatibility, or I can say consistency. And you can see the complete explanation is given here. Whatever we have seen, that is written here. We have seen this question using two methods, by case method and truth table method, and both of them I hope you understood. Let's solve this question from UC Davis University, Samuland Island. Actually, what is this Samuland Island? You can see Knight-Knave question. So let me tell you, today you can Google. There is a book. And what is the name of the book? Can you guess? The name of the book is, what is the name of the book? And this is written by Raymond, I think Raymond Smullyan. Okay, so maybe I'm doing the wrong pronunciation. I'm sorry for that. But this book contains logical puzzles. This book does not contain those type of puzzles that you see in the newspaper ki do aksar ka mera naam ulta sulta ek saman. No. Okay, in the newspapers we have this type of puzzles, right? मैं हूं लाल, मैं हूं ये, मैं हूं दिन में, हर मैं दिन में निकलता हूं, गेस करो मैं क्या हूं. No, this type of dumb puzzles are not there in this book. So basically there is a book. The name of the book is, what is the name of the book? This is the name of the book, and this is written by, I think, Raymond Smullyan. You can check it out if I'm making any mistake here. The surname is Samuland, basically Smullyan. And basically in this book you have logical puzzles. The Knight-Knave puzzles were initially, or I can say the first time the Knight-Knave puzzles came into existence in this book. Okay, so if someone asks you who was the person who started these Knight-Knave puzzles, and nowadays these are very famous in the philosophy, in the discrete mathematics, in the propositional logic, these are very famous. Questions have come in the gate exam based on Knight-Knave puzzles, and these Knight-Knave puzzles were for the first time, these were written, these were given in this book. You can download it. I remember that when I was preparing for the gate exam in 2017, 2016, when I was preparing for the gate exam, and I got to know about this book, then I and my friend, we used to discuss these puzzles. Of course, as a gate aspirant, you don't have to do it. Basically, what we used to do, I and my friend, we were basically, whenever we are traveling in the metro, if we are traveling, then during that time we used to discuss these puzzles, the logical puzzles of that book. So we downloaded that book and we started discussing those puzzles. You can download the book, and maybe after, after the gate exam, maybe you can just go through those puzzles. You can try to solve those puzzles. These are all logical puzzles. Okay, your logical brain, you have to apply too much, I can say. So I hope it is clear. Now let's see. So let's solve this question. Samuland Island. On this island, there are two type of people, knights and knaves. You can see this is a very special island that has only two type of people, knights, knaves. Knights will always tell the truth. Whatever knight will speak, that is true. Whatever knave will speak, that is false. Knaves always lie. You meet three people, Alex, John, and Sally. On this island, you meet three people. Alex says something, John says something. Can you find what are Alex, John, and Sally? Here you can notice, if you apply the truth table, then there will be total 8 cases because we have three people here, Alex, John, Sally. We have to consider total 8 cases. If I make the truth table, you know, maybe all are knight, maybe all are knave, knight, knave, 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 knight, knave. So you can see total 8 cases will be there if I make the truth table. So tell me, for this question, the truth table method will be efficient or not? What do you think? For the previous question and for the previous two questions, we have applied the truth table method, correct? The gate mechanical question and the lady tiger question. For the previous two questions, we have applied the truth table method because there the truth table was having only 4 rows. We were checking only the 4 rows we were checking. But tell me, for this question where you have three people, so total 8 cases will be there. Each person can be either knight or knave. Each person has two possibilities. Three people are there. Each of them has two possibilities. So total eight rows, or I can say in the truth table, total 8 rows will be there. So tell me, will you apply the truth table? No. Here you apply the by case method. Okay, so let's solve this question using the by case method. Of course, you can apply the truth table also, but it will be time consuming. So what you do, you just apply the by case method. So let's apply it here, by case. Now, what are the cases I will consider? First, I will write what they are actually speaking. Okay, first let me write whatever the information is given in the question. First, let me write that, and then we will see the by case method we will apply. So you can see these three people are there, and what Alex is saying. Let's write what Alex says. Alex is saying that John is a knight if and only if Sally is knave. If and only if Sally is knave. Okay, so basically you can see, read this complete statement. John is knight if and only if Sally is knave. So I can say that John is knight if and only if Sally is a knave. Okay, please understand that I'm using this N for knave and I'm using this K for knight. Okay, this is what I'm using. So here you can see JK. What it means? It means that John is knight. What this means? JK means John is knight. Okay, and only two possibilities are there. John will be knight or John will be knave. So you can see that if I write negation of JK, then that will be JN. Means if J is not knight, if John is not knight, then John is knave. Correct? Similarly, you can see if Sally is not knave, then Sally will be knight. Negation of knight will be knave. Negation of knight will be knave. Negation of knave will be knight. Negation of knight will be knave. Okay, correct? These things you already know. Now here you can see the Alex is saying that Joan is knight if and only if. This means if and only if. Joan is knight if and only if Sally is knave. And what Joan is saying, you can see Joan says if Sally is knight, then Alex is knight. This is what Joan is saying. Joan is saying that if Sally is knight, then Alex is knight. Means if Sally is knight implies Alex is knight. Okay, this is what they are saying. Now we need to find out Alex, John, Sally, what they are. Okay, so this is the information that is given here. So basically, remember the given info that what Alex is saying. Alex is saying that John is knight if and only if Sally is knave. And what John is saying, John is saying that if Sally is knight, then Alex is knight. Okay, if Sally is knight, then Alex is knight. So this is given in the question. Now let's see. Now I can make the cases. So for what I will do from Alex point of view, let me make cases. So you can see that case number 1, what that will be? That will be that Alex is knight. Either Alex will be knight or Alex will be knave. Do you agree? Case number 2, that is Alex is knave. Only two cases are possible. Either Alex will be knight or Alex will be knave. Now let me consider this case where Alex is knight. If I am already assuming in the case 1 that Alex is already knight, so whatever Alex is saying, that must be true. Yes or no? Alex is already knight. So it simply means that JK by implication SN, this is true. Okay. Now you can see from here what I can say. JK and SN, what I can say about them? There are two possibilities. What are the two possibilities here? Because remember, by implication, this is true. It means either both are true or both are false. Do you agree? So I can simply say that there are two cases here, though there are two possibilities that it can happen that JK is true, means Joan is knight, then SN is also true. Okay, because notice this by implication is true. It means either both are true or both are false. So either JK true, SN true, or JK false, SN false. JK false, SN false. Okay. Now notice if I say that when I say SN false, it simply means SK true. Means if Sally is not knave, Sally being knave is false, so Sally will be knight. John knight false, so John will be knave. Okay, yes or no? So very simple point. Now, so in this case 1, now let's come to what John is saying. Now notice here again I have to create cases. In this case 1 also sub cases I will need to create. Because please understand what John is saying. Here you can see this is the AK. And see, I am saying that in this case 1, now let's come to what John is saying. John is saying that SK implies AK. Okay. Now here you notice one thing. This AK is already true. This is already true in case 1. Correct? This AK, Alex is knight, that is already true in the case 1. So AK is definitely true here. In this case 1, AK is definitely true. Now what John is saying, John is basically saying the truth. Yes or no? Can you notice? Because anything implies true. What that becomes? Anything implies true, that becomes true. Okay, correct. So look at the case 1. In the case 1, Alex is knight. If Alex is knight, then this will be true. Means John is speaking the truth. What John is actually speaking, that is true. Anything implies Sk implies true, this whole thing will be true. I can say that here anything, Sk can be anything. It can be true or it can be false. I don't care. The point is anything implies true. That is true. That is true. So it means what? It means John is what? John is speaking truth. John is speaking truth. So John is knight in this case one. We are considering case one. In the case one, Alex is knight. In the case one, John is also knight. Now tell me, if John is knight, then here we have two cases. Which case actually will be true? John is knight, right? Okay, so you can see if John is knight, then it means that this case is gone. If John is knight, then definitely this will happen. Correct? This will happen because this will happen. Why? Because John is knight. Because we found John is knight. Because we found John equal to knight. So if John is knight, then here you can see this Sn will be true. So here I can say Sally. Sn will be true, means Sally is knave. Okay. Now you tell me, so far did we get any contradiction anywhere? We did not get any contradiction anywhere, right? Notice in this case one, we did not get any contradiction because in the case one, Alex is knight. In this case one, if you see finally what we got, and then let's check the consistency holds or not. See, in the case one, what we got, let me write what case one is giving us. So here, let me write here that so what case one is giving us. Case one is saying that Alex knight, John knight, Sally knave. This is what case one is giving us. Now let's check. Using this means if Alex knight, John knight, Sally knave, then these are consistent or not. You can see if Alex is knight, then this will be true. Okay, so basically what I'm saying is that you check the consistency. So let's continue from the previous page. Okay, from previous page. From the previous page, I am continuing. So you can notice that here what we found that Alex, John, and Sally, they are knight, knave. Correct? This is what we found. And you can see what Alex was actually saying. What actually speaks? He speaks that John is knight if and only if Sally knave. And you can see what John speaks. John speaks that if Sally knight, then Alex knight. Okay, this is what they are actually speaking. So you can see this is what they actually speak. They actually speak this. Now let's check the consistency. Here you can see in this case what Alex actually speaks, you find the truth value of that. Okay, so you can see the truth value. What Alex actually says, its truth value you find. Okay, then what you do? You find what John actually says, you find that truth value also. What John actually says, you find the truth value of that also. And then you check the consistency. Then here you check consistency. So tell me, you can see in this case, one thing is clear that Alex is knight, so this will be true. correct? This will be true because Alex is knight, so this is true. Anything implies true, that is true. So what John actually speak, that is true, correct? What John actually speaks, the truth value is true. Now let's see what Alex actually speaks. You find the truth value of that. You can see Sally is knave, so this is true. And you can see John is knight, so this is true. True by implication, true. That is true. Okay, now let's check the consistency. You can see if Alex is knight, then what Alex actually says must be true. Yes, that is true. Consistency is there. If Alex is knight, then what he actually speaks, that must be true. And yes, that is true. John is knight, so what he actually speaks, that must be true. Yes, that is true. And Sally does not speak anything, so there is nothing to check. Sally does not speak anything, yes or no? So yes, consistency is there. That's it. This is your answer. Is this clear? You don't even have to check other cases. But remember one thing. Let's assume this question comes in the gate exam, and one of the option is that you cannot determine the truth value. See, let's assume this question comes in the gate exam. Do you remember the gate mechanical question that we solved? The first question that we solved, there you can notice that two cases were consistent. Both knight, both knave, both the two cases were consistent. So when more than one case is consistent, then we can say that we cannot determine the correct case. Yes or no? If multiple cases are consistent, then we cannot determine which is the actual case. Yes or no? So the answer will be we cannot determine. You can check the first question, the gate mechanical question. Now look at this third question. In this third question, you can notice if this question comes in the gate exam and the options do not contain, that we cannot determine. Basically, let's assume the options are like, Alex is knight, Alex is knave, John is knight, John is knave, like that. If you have four options, then you can stop here and you can tick the question. You can tick the answer. Are you getting my point? But remember, in the gate exam, if this question comes and one of the option is that we cannot determine the truth value, then what to do? Then we have to check the case 2 also. So far, we have checked case 1. Only two cases are possible. Either Alex will be knight or Alex will be knave. One case we have considered, one case we have checked, another case we need to check. I hope it is clear. From the truth table point of view, 4 rows we have checked because we have checked the case where Alex is knight. When Alex is knight, then there are 4 possibilities for John and Sally. Basically, in the case 1, those 4 rows of the truth table we have checked. Now, in the gate exam, if one of the option is that we cannot determine the truth value of Alex, Sally, John, if this type of option is there, then you should remember that gate mechanical question. That maybe there is another case also. Maybe in the case 2 also, I can find something where consistency holds. If there are multiple cases where consistency holds, then we cannot determine the answer. Then answer will be that we cannot determine. But if only one case holds, means there is out of the 8 rows of the truth table, if there is only one row of the truth table where the consistency holds, and for the remaining 7 rows the consistency does not hold, then we got our answer. That okay, this is the answer. We can determine the answer and we found the answer. I hope you are getting the point. For this question, I can stop right now, depending on the options. But let's continue and let's check the case 2 also. Because by any chance in the gate exam, fourth option is that we cannot determine, then you have to check case 2 also. You cannot stop at case 1. Think about that gate mechanical question. In that gate mechanical question, if some student stops at night, some student takes the case 1 night, and the case 1 is consistent. If the student stops there, then there is a problem. He will get the wrong answer because the knave also holds. Knave is also consistent. Knight is also consistent. I hope you are getting my point. Okay, so that gate mechanical question is teaching you a lot of things. In this session already, the gate mechanical question we have solved, that is teaching a lot of things. So now let's continue and let's see the check. Let's check the case 2 also. But in the gate exam, depending on the option, you should determine. You should make this decision. Should you go for case 2 also or not? Depending on the options. So depending on the option, either I can stop here or I can continue. Now let's continue. So now let's check the case 2. The case 1 we have checked. Now let's check the case 2. The case 2 is that Alex is Nave. Now, if Alex is Nave, then what Alex is speaking, that must be false. Alex is Nave. So in this situation, what should happen? What Alex is speaking, Alex is speaking this statement, this must be false. Now, if by implication is false, then how many cases are possible? Two cases are possible, correct? When by implication is false, then two cases are possible. What are the two cases? When the by implication is false, then this might be true, this might be false, or this false, this true, correct? This is by implication. So definitely true false or false true. These are the two possibilities. So I can say that you can see either it will happen that Joan Knight JK true SN false. Okay, or what can happen? That JK false SN true. Okay, correct. Very good, very good. Now let's see here. If SN false means if Sally Nave is false, then Sally is Knight. Then Sally is Knight. Here you can see if JK false means Joan Knight is false, then Joan must be Knave. Okay, basically there are two possibilities that both Joan and Sally they are Knight, or both Joan and Sally are Knave. Correct? So you can see in this case too, Alex is Knave. So what Alex is speaking, that must be false. Now you can notice one thing. In this case too, if Alex is Knave, then this will be false, because in this case too, Alex is Knave. So Alex Knight will be false. Correct? Yes or no? I hope you got it. So you can see that here I can say if Alex is Knave, so Alex Knight, that will be false. So what John is saying, SK implies false. What is alpha implies beta? Alpha implies false. Alpha implies false. What that is? You can see I can write it alpha bar or false, so that will be alpha bar. Correct? You know that P implies Q, that is P bar or Q. So let's see here. You can see what John is saying. John is basically now what John is saying. John is saying that SK complement. So I can say what John is saying. John is basically saying that SK is means cell is Knave. This is what John is saying. John is saying Sally is Knave. Okay, because John is saying selenite is selenite negation. You can see John is saying selenite negation. So I can say that John is saying Sally Knave. Okay, now what to do? If Sally is Knave, if Sally is Knave, you can see we are just going step by step. So you can see John is saying this. Now here I need to make two sub cases. What are the two sub cases? John is Knight or John is Knave. Correct? Yes or no? See, in the case 2, we are already assuming that Alex is Knave. If Alex is Knave, then we are just finding everything else. Now here you can see what John is saying. John is saying that Sally is Knave. But I don't know whether John is Knight or Knave. Please understand. I don't know whether John is Knight or Knave. If John is Knight, then SN is true. If John is Knave, then SN is false. Are you getting my point? In this case too, I know Alex is Knave. But in the case too, I don't know whether John is Knight or Knave. So what should I do? I should make sub cases. So let's see sub case. Sub case 1. Sub case 1 is that John is Knight. And what is sub case 2? Sub case 2 is John is Knave. Okay. Now let's see. In the sub case 1, where John is Knight, In this case, if Joan is knight, so what I can say, what Joan is speaking, that is truth. Correct? So in this case, what Joan is speaking, that is true. Okay? And you can see, so I can say that Joan is speaking truth. So definitely I can say that Sally is knave. Okay, yes or no? Sally is knave. So you can see, if Joan is knight, then definitely in this case Sally will be knave because John is knight, so he is speaking the truth. So I can say Sally will be knave. So now let's check, if John is knight and Sally knave, then that there is a contradiction, because here you can see that either both will be knave or both will be knave. Sorry, either both will be knave or both will be knight. John, Sally, both will be knave, both will be knight. Correct? Yes or no? So there is a contradiction here. Did you notice the contradiction? The contradiction. Let me show you the contradiction. Here the contradiction is that you can see John is knight. So what John is speaking, that is truth. So you can see Sally is knave. So you can see what we got. We got that okay, John is knight and Sally knave. But this is a contradiction, because you can see here either it will happen or it will happen. So either John, Sally both will be knight, or John, Sally both will be knave. How can it happen that one is knight, one of them is knave? So this is the contradiction. I hope it is clear. Okay, so in the sub case 1, there is a contradiction, so discard. Now, the sub case 2, if John is knave, then in that case, what John is speaking, that is false. John is speaking that Sally is knave. So this is false. What it means? It means that Sally must be knight. Again, there is a contradiction here. Again, there is a contradiction. What is the contradiction? Tell me. The contradiction is that John is knave, Sally knight. John is knave, Sally knight. You can see already we know that either it will happen or it will happen. Means either John, Sally both will be knight or both will be knave. So it cannot happen that one of them is knight, another is knave. So sub case 2, that is also discarded. That is also discarded. Okay, I hope it is clear. So that's it. So I can say in the case 2, there are two sub cases, both are discarded. So I can say case 2 is discarded. So the answer will be the case 1 only. And the case 1 was Alex is knight. And in the case 1, we have seen that if Alex is knight, then John will be knight and Sally will be knave. So the final answer we have seen. I hope it is clear. Okay, so let me just give you the summary. Let me just summarize how we solved it. This question, how we solved. So let me summarize. Basically, we created two cases. The case 1 was Alex knight. This case we created. Then we created case 2, that was Alex knave. Okay, two cases are possible only. Yes or no? Either Alex will be knight or Alex will be knave. Now, you can see in this case where Alex is knave, in this case we created two sub cases. We created two sub cases. Sub case 1 and 2. Sub case 1 was John knight, and the sub case 2 was John knave. Either John will be knight or it will be knave. So you can see that, remember, only two cases are possible. Alex will be knight or Alex will be knave. When Alex is knave, then only two cases are possible. John will be knight or John will be knave. Okay, yes or no? Now, what we saw in this case we saw that there was no contradiction, and here we got that okay, Alex was knight, John was knight. We found out. We found that Alex, John are knight and Sally knave. This is what we found. Here I can say. Here I can write that okay, we found. We found. This is what we found. And this was consistent. Or I can say no contradiction. There was no contradiction at all. There was no contradiction. Very simple. But remember, in the case 2, where Alex is Nave, in the case 2, in these sub cases, we found the contradiction. Here also we found contradiction. Here also we found the contradiction. Okay. So that's it. Finally, this is what we have done basically. This is how we have solved the question. I hope you understood this. What is another way to solve this question? Truth table. You create truth table, total 8 rows will be there, and for each row you check the consistency of the given statements. Okay, consistency of everything that is given in the question, you check the consistency of that. Now let me tell you, you can try that. Okay, this is a homework for you, that you solve this question using the truth table method. Alex, John, Sally, you create total 8 rows in the truth table, and for each row you check what they are speaking, what they are actually speaking, you find the truth value of that, truth value of what they are actually speaking, and then you check if consistency holds or not. Okay, what Alex is actually speaking, what John is actually speaking, Sally is not speaking anything. So what Alex is actually speaking, what John is actually speaking, you find the truth value for each row, and then you check if consistency holds or not, and you will find that there is exactly one row where the consistency will hold. For the remaining 7 rows, the consistency will not hold. So this is your homework. Okay, take this question as a homework. Please do it for your benefit. Maybe someday this truth table method can help you. Okay, if by case method becomes confusing, if you if the question is complicated and the by case method becomes very confusing, then the truth table method you can apply. That is straightforward method. The beauty of truth table method is that that is very easy. Okay, but the by case method is time saving. If you have to make total 8 cases, if the truth table has total 8 rows or 16 rows, then the by case method will be time saving. If the truth table only has 4 rows, then 4 rows or 2 rows, if the truth table has, then truth table method will be more efficient. So you have to decide for this question which method will be more efficient. The truth table method is much easier for this type of question, for this type of puzzles, but the by case method can save a lot of time if the truth table contains 8 or 16 rows. Okay, I hope you understood this complete thing. Now let me tell you that you solve this question right now. You pause the video and try the truth table method. Okay, try that. You pause the video right now, because now I am going to show you the the official answer is using the truth table method. Okay, so before you see the answer, before I show it to you, you just pause the video, you try the truth table method yourself. Okay, and then let me show you, this is the official answer. You can see the university has already given this official answer, and you can see this is using the truth table method. You can see total 8 rows are there, and they are checking the consistency or compatibility. You can see there is exactly one row where consistency holds. For the remaining rows, you can see the consistency does not hold. This is the complete explanation given by the university. You can pause and you can read it. Okay, so that's it, everyone. We have completed the discussion of today's DPP. Remember, your support will decide the future of our YouTube DPP series. Please show interest, please participate, please put a comment, please share your feedback, press the like button, share with all the Gate CS, Gate D aspirants, and we will keep bringing to you new unseen standard questions to solve. All these questions will be within the Gate syllabus, and the difficulty level will be within the Gate difficulty level. Okay, and remember the GOAT DPP series, our Go Classes YouTube DPP series. The complete playlist link you can find in the description, also in the pinned comment. On YouTube, you can search Gate CS DPP. Just put it on the YouTube, Gate CS DPP, and our Go Classes DPP videos will start showing. Okay, you can see, and here there is a playlist link. You can see Gate CS GOAT DPP series playlist link. The complete playlist link you can find here. This is the playlist. You can see this is the complete playlist, so you can just check out this playlist. Okay, so that's it, everyone. These 3 questions were quite heavy, I can say, right? Do you agree with me? I only gave 3 questions in today's DPP. If I gave 5 questions, then I thought that let's keep it light. Of course it was not light. Even these three questions, you will feel, they were really, these puzzles are beautiful, these are logical puzzles. Okay, in the future DPPs, alternatively, or sometimes I will keep bringing this type of puzzles from the standard resources. Knight-Knave puzzles, lady tiger puzzles, this type of puzzles based on the Knight-Knave template. More and more questions I will keep bringing to you in the future DPPs. Okay, three questions today we have solved, and in the upcoming days, at least 20, 30, 50 questions we will solve. So you can see, once you solve 20, 30, or maybe 50 questions based on this template, once you solve these many logical puzzles, your propositional logic will get revised. This type of puzzles, if they come in the gate exam in future, you will be able to solve very quickly. Okay, you will be more confident because you have done practice, you have done practice of 50 such questions. So in the upcoming, in the future DPPs, I think I will solve at least 30 questions or maybe 50 questions of this type. Okay, but not consecutively, alternatively. Okay, sometimes, like maybe after every 4 or 5 days, this type of puzzles I will bring to you. Okay, after every 3 or 4, so I will see when to bring. But the point is, in the future DPPs, more Knight-Knave type puzzles, more this type of puzzly questions you will find. Okay, so thank you everyone. If there is any issue, any doubt, I can see in the chat a student is asking about some scholarship test interview. If there is any issue, any doubt, after this session is over, please put in the comments. I will reply myself. Okay, so thank you.